Fibers over there. It's delightful. And today's cosmology segment, we'll talk about galactic formation. So, back in the mid-90s, people thought that elliptical galaxies were actually highly evolved galaxies. But now it seems that people believe that elliptical galaxies are less evolved galaxies. Ultimately, the answer is that we don't know. And what elliptical galaxies are, now most people are used to galaxies that have a spiral shape to them. Elliptical galaxies are galaxies that look like this, where it's basically just spherical or oblong in shape, and it doesn't have any particular cigar shape if it's viewed edge on, or a spiral shape if it's viewed down the poles. It's an elliptical galaxy. And when we look at very distant galaxies, we see a lot of elliptical galaxies, an indication that perhaps elliptical galaxies are an evolutionary stage of galactic formation. Here's an article on phys.org which throws the theory of galaxy formation on its head. Now, what you're looking at here is radio interpolated imagery, which is showing you the motion of gas. So in this image here, the blue gas is moving toward you, and the red gas is moving away from you, indicating that it's rotating. And this particular elliptical galaxy has all kinds of, well, it's not really a fully elliptical galaxy. It's got all kinds of features in it. In other words, we're looking at a galaxy that's estimated distance is like 10 billion light years away, somewhere on that scale. And it has features like spiral arms. So that's not understood. Galaxy formation is not understood. So this one's probably believed to be about something like 11 billion years away. And there's an image of it, and you can see some evidence of some spiral arm features and so on, features not expected to be seen in such a distant galaxy. Believed to have formed just 1.2 billion years after the alleged Big Bang. So you see a massive bulge, a regular rotating disk, and possibly spiral arms, which is not expected. The galaxy looks like a grown adult, says somebody who's not credited with this quote. Co-author Dr. Timothy Davis from the School of Physics and Astronomy said, "This spectacular discovery changes our current understanding of how galaxies form because we believe these features only arose in mature galaxies, not in young ones." You can find that article on phys.org in the Astronomy and Space section. Let's pick a random number and look at the Neil Gorell Swift-Bat X-ray Observatory. Today's random number is 858. We choose a quantum random number regularly on the channel to do a cosmology segment, and 858 coincides with an object here at the Burst Alert Telescope, 858. What do we have? It's Pulsar J1907 plus 06, a pulsar, most likely located in the Milky Way galaxy. And you can see it's a pretty consistent X-ray source, as seen in this graph up here in the upper right. There are the daily transients from it. And let's see if we can get some imagery to provide oohs and ahs from our viewers. And we don't see it in those optical wavelengths. Not to be discouraged, let's see if it shows up in infrared. And it does not. Let's check the multi-mirror project. The XMM Newton, not really showing up there, barely a signal, and not even on the crosshair. How about the Chandra? And we can see it on the Chandra. It's pretty dim. It's Pulsar J1907 plus 06. And we won't go any more in depth into that. If you want to follow your favorite transients on the Neil Gorell Swift-Bat X-ray Observatory, well, just go to the Neil Gorell Swift-Bat X-ray Observatory and type in your favorite object. So, for instance, let's see what's going on with Cygnus X3, the brightest intrinsic object in the Milky Way galaxy visible from Earth. And it's gone into an extremely loud X-ray state. It's all the way up here, which is near the top portion of its range. 0.04 coincides with this, historically speaking. So the last about 10 days, of the outputs of Cygnus X3 in X-ray are quite dense and quite high energy, as seen there in the chart. Other objects you may want to watch over there are, oh, I don't know, how about Sagittarius A star? That's entry number 691. There are the outputs of the core of the Milky Way galaxy in X-ray. And that's today's cosmology segment. We don't want it to be too long. Perhaps we'll talk more about that pulsar at a